We are going on with grade 10 exponents, and in this video we'll do some examples on the laws of exponents. Let us look at our first example. Here we have negative 2a to the power of 3 times ab to the power of 4 squared. And what we want to do is simplify. So first, let us recognize that we cannot do anything with the negative 2a to the power of 3 yet. First, let us remove the brackets, and we'll do that by multiplying the 2 into the exponent of b and to the exponent of a. So we'll have negative 2a to the power of 3 times a to the power of 1 times 2, b to the power of 4 times 2. And this 1 comes from a, because there's no exponent of a, then that is 1. So let us quickly simplify. So we have negative 2a to the power of 3, a squared, b to the power of 8. Now the next law of exponents that I can use is by adding the exponents together when the bases are the same. So we'll have negative 2a to the power of 5, b to the power of 8. Notice that I'm only adding the exponents of a together to get to a to the power of 5. And that's our first example. In our second example, we'll apply the law of division. Here we have a fraction, so we are going to apply the law where we subtract exponents from one another. But before we do that, we see that we have two coefficients, 4 and negative 2. Now these are not exponents, so I won't say 4 minus 2. I will actually ignore the variables and simply simplify 4 divided by negative 2. And that answer is negative 2. Now I am done with 4 and 2. So let us move on to the exponents. So I have x to the power of 3, and I'm going to subtract 5 from it. So remember, the law says if the bases are the same and we divide, then we subtract exponents. The same goes for y. So I have y to the power of 5 minus 2. And if I simplify that, I have negative 2, x to the power of negative 2, y to the power of 3. Now normally you would think that you are done with this calculation, but in algebra, we always want to leave our exponents as positive values. So we are applying the law that says if I have x to the power of negative 2, I can rewrite that as 1 over x squared. So all that I'm simply doing is I'm rewriting x to the power of negative 2 as x squared in fraction form. So in our final answer, we have negative 2 as our coefficient, y to the power of 3 in the numerator, and x squared in the denominator. In our third example, we are multiplying two terms with one another. But before we work with the variables and its exponents, let us look at the coefficients. So I have 3 multiplied with minus 5. So when I ignore the variables, it simply becomes 3 times negative 5, and that is equals to negative 15. So now I'm done with the 3 and the negative 5. Let us move on to the exponents. So I have x to the power of negative 2 and x to the power of 3. And when we multiply, we add the exponents together. Next, we have y to the power of 4 and y to the power of negative 2. So this becomes y to the power of 4 minus 2. Notice I'm not adding negative 2 and 4 and 3 and negative 2 to create one big value. That will be incorrect. I can only add exponents where the variables are the same. So if I simplify, I have negative 15, x to the power of 1, y squared. And we can also leave our answer as negative 15x y squared. In our fourth example, we have negative 3 multiplied with a bracket raised to the power of 0. Now what we know is that anything raised to the power of 0 is equal to 1. So the whole set of brackets would become 1, because everything on the inside of the bracket is raised to the power of 0, and that simply becomes 1. Then negative 3 times 1 is equal to negative 3. Okay, let us look at our last example. Here we have a division sum again, but notice we have negative exponents. So first, let us work with the coefficients. So 2 divided by negative 4 would be equals to negative 1/2. Now some might argue that this must be negative 1/2, but that's the same as saying negative 1 over 2, and that's also the same as saying 1 over negative 2. My personal preference is to leave the denominator as a positive value, so even though all three of these fractions are correct, I would like to place the negative in the numerator and leave the denominator as positive. Next, let us work with the exponents of p. So when we divide, we'll take p to the power of minus 2, and we would subtract the exponent at the bottom, which is negative 1. So notice it is negative 2 minus negative 1. And it's a double negative, and two negatives next to one another, when we multiply it, becomes positive. So if I simplify, this would be negative 1, p to the power of negative 2 plus 1 over 2. And if I simplify further, this would be negative 1, p to the power of minus 1 over 2. But in algebra, it's good practice to leave our answer in positive exponents. So I'll take the negative 1 to the denominator.